293 groups of spatial equivalent strings. So currently, I've always been solving the Leetcode tree problem, but that is so noisy, so boring. Let's just try to solve some other problem. Maybe it's gonna be more interesting. So for this problem, actually, it means we are giving a list of words. So inside it's gonna be the strings, and each of the word inside it's gonna be the same length. So for example, the length is gonna be 4 for each of the word, and for the second one, each of them, the length is gonna be 3. Let's check the result. So the constraint for the word's length is 1000, the word's I length is 20, and it is always lowercase English letters, and all the strings are with the same length. So for actually, this means for solving this problem, we can use 1000 times 20 for the time complexity. It seems it is okay. It seems like m times n. So we are going to return the number of groups of spatial equivalent strings from the words. So the group, let's just check the definition of the group. Actually, the definition is also easy to understand. So the two strings, word I and word J, are spatial equivalent if after any number of moves. Yeah, so the move is, we can, yeah, let's just check what is a move. So we're gonna check this condition. So for every pair of strings in the group are spatial equivalent, and the group gonna be the largest. Yeah. So let's just check what is a move. So in one move, we can swap any two even index characters or any two odd index characters of a string. Yeah, so let's just check this example. So for z, z, x, and y, and x, y, z, z, they are equivalent. Let's just check y. So we can, first of all, we can just change the even index. This z and this x, so it's going to be x and z. And then we're gonna check swap the odd index. So this z and y gonna be swapped. It's gonna be y and z. So after that, it's gonna be x, y, z, z, and x, y, z, z. So it's gonna be the equivalent. So we're gonna return the number of equivalent groups. So for example, this is a group, and this is another group, and this is gonna be the third group. So we're gonna return a 3. So how can we solve it easily? I think the obvious idea is that we're gonna use a hash table. And inside the hash table, we're gonna put them as a group. So this is a group, this is another group, and this is a third group. But what's gonna be the k? So according to the greedy idea, if we can sort the even indexed characters and we can sort the odd indexed characters, definitely it's gonna be okay. So for example, this is just values inside the dictionary, and what's gonna be the k? So for the k, we can sort it. So for a and c, it's going to be the even index. So after sorting, it's going to still be a and c. And for this b and d, it's going to be the odd index. After sorting, it's going to still be b and d. So this a, b, c, d going to be the k. And inside the array, it's going to be values. Yeah, because for example, this one, ca, it's going to be sorted to ac, and db is going to be sorted to bd. So it's going to be a, b, c, d. And those array going to be the values. And we just need to check the length of the dictionary, and that's going to be the final result, because the length of the dictionary is going to be the number of groups. Now let's just use this kind of idea to solve the problem. So we're going to prepare a default dict as a list, and finally we're going to return the length of the dictionary. Now let's just check that. So for every word inside the words, we're going to prepare the k. So k, I'm going to prepare a function. It's going to be check. So check this word. Gonna append the value of the word. Yeah. Or you can also use a set. It's the same idea, but I prefer to use a dictionary because anyway I can solve it. Yeah. Now let's just finish this check function. The check function is just to check how many groups. So let's just use this check for a word. Yeah. So for this check function, actually for a word like CDBA, we just want to turn this word to ABCD. And how can we turn that? And we just use the even index and odd index characters and sort them. Yeah. So first of all, let's check take out the even indexed characters. So it's going to be, I will put it inside a list because I will sort it. So it's going to be the word with even index. it's gonna be 0 to the final word and with a step of 2. So this is going to be the even indexed characters, and we're going to connect them together and put them inside a list. And also for the odd, it's going to be the list of word. So we're going to start from index 1, and we're going to have a step of 2. So this is going to be the odd index characters, and we're going to put it inside an array. And now we can sort it. Sort, and we're going to prepare a result as empty string, and we're going to use a zip to check all the characters. So for AB, let me use for AB in zip with even first and then odd. Yeah, so my result is going to plus equal to plus A plus B. And finally, I need to check. So maybe the even is longer than the odd, but definitely the even going to be more than and equal to the odd. I mean the length of the even. Let's just have a check. So if the length of the even is more than the length of odd, we need to plus the actual value, because the zip is just compare. If this even equal to the odd, it is okay, but if they are not equal, the length of the even may be longer, but for the zip, it will just choose the shorter ones. Yeah, but what left behind is we're gonna have a final check if this length of the even is more than the length of the odd. So we're gonna plus the even with the last character. So finally, we're gonna return the result. Yeah. So I think the difficult part may be about here, but you can write any kind of a function to realize this kind of a sorting. And basically, it's a sorting. You're gonna take out the even and take out the odd characters and sort them, and then combine them together. So this is just the idea. Now let me just run it to check. As you can see, it works. Now let me submit it. As you can see, it works, and it's pretty fast. So the time complexity gonna be because we use the sort. So because we sort an array, because we sort all the word actually. We didn't sort the array. We sort all the word. So the time complexity gonna be 1000 times 20 times log 20. So it's gonna be basically it's gonna be n times m log m, and this m gonna be only 20, so it's gonna be a small value. That is why it's so fast. Thank you for watching. See you next time.